First, we will be interviewing all the parts of cellular respiration. We will start with glycolysis.
Yo, what's poppin', B? It's your boy, Glycolysis, coming at ya.
So, glycolysis, where do you do your work?
My department is in the cytoplasm.
And what do you need to complete your job?
I work with main man's glucose and ATP.
Why are you valuable to cellular respiration?
I create NADH, 2-pyruvate, and a little bit of ATP.
How effective are you at producing ATP?
Not very, considering I only make 4. Technically even 2, because I use 2 of them in the process. So really, I only make 2 ATP.
Alright, thanks for talking to us.
Yo, we'll see you later, fams. Thanks, Tom. And now, we have an exclusive with the, Krebs Cycle.
It's Krebs Cycle.
Okay. Well, first off, where do you do your job, Mr. Krebs?
The mitochondria, specifically the matrix of the mitochondria.
Interesting. What do you consume while performing your job, Mr. Cabs?
It's Krebs. I enjoy a heaping helping of acetyl-CoA.
From the oxidation of pyruvate.
And what do you expel, Mr. Creams?
I am very versatile in that I can make NADH, FADH2, CO2, and ATP.
Alright, now for the big burning question, Mr. Carbs.
Krebs.
Yeah, sure. Mr. Kebs. How much ATP do you produce?
Everybody wants to know, and I am sad to say I can only make 2 per cycle.
And finally, we have the privilege of talking to the electron transport chain.
Yo, what's up? Get this out of here. It's your boy, the Electron Transport Chain, coming at ya. Ooh, from the inner membrane of the mitochondria. Can I get a what? Let's go. Get this interview done. I got a meeting in the morning. Actually, I got a meeting in 15 minutes. Let's go.
Can I have your autograph?
Sure, kid. Keep it. It'll be worth something someday.
Thank you. What reactants have the honor of being used by you?
I got my boy O2, NADH, and FADH2.
And what do you produce?
I produce a little bit of H2O and a grand 34 estimated ATP.
That is most impressive. Thank you for your time.
Real quick, I gotta explain my side project, chemiosmosis. Basically, hydrogen ions are moved from NADH through mitochondrial fluids against the concentration gradient. Then they go back with the concentration gradient through ATP synthase, making ATP, and finally to 2 oxygen to form 6 H2O. Now we're moving across the street to photosynthesis. My man, what department are we in right now?
This is the thylakoid membrane.
Alright, what's going on with you? What's the reaction?
Here I use light, H2O, and NAD+, to make O2, ATP, and NADPH. Oh wait, sorry. I use NADP+. Just had to clarify.
Okay, sure you did.
Can I get back to work now?
Alright, whatever, kid. Moving on!
That was a very intriguing interview, Scott. Now we have the largest part of photosynthesis, the Calvin cycle.
Hello.
And which department is this?
This is the stroma.
And would you mind telling me what you do here?
Yes. No. What's the right answer?
Just tell me what's going on.
Okay. Well, first I use CO2, ATP, and NADPH to go through carbon fixation, then reduction, the releasing of G3P, and the regeneration of RUBP, respectively. In all, I release 1 G3P, or 1/2 of a glucose per cycle.
Perfect, thank you. This is the conclusion of our interview.